Right. Hello, everyone. My name is Fabian Barkow. I work for the Storj team, and so I'll just talk a little bit about about the topic today, and then just feel free to interrupt me at any time for questions, and then we can go over to more questions later on. I want to keep this as a more dynamic, like conversation Q&A thing. So I'm not actually going to really present anything unless you ask for information or such. Then afterwards you can ask more broader questions about Storj itself, about general comp sci, bicycles, whatever you feel like. So I guess I should start off on what is Storj. At its core, like at the most basic level, Storj is a peer-to-peer market for storage. And the question is, if you're going to make a market for storage, how are you going to implement this market mechanism? And so what it usually all boils down to is some PubSub system. It's a very simple algorithm that everyone knows, or rather very simple, yeah. And so the problem with a peer-to-peer system in a PubSub is that most PubSub implementations require you to trust the nodes, and that's the basic problem, or that you have control over all the nodes. And in a peer-to-peer market system, you cannot really control the nodes. You don't necessarily trust them all. Maybe because it's a market mechanism, someone wants to suppress the offers of their competitors. There's a whole bunch of problems with this. And so we were looking around for papers on peer-to-peer PubSub systems that would be sufficient to implement a market mechanism. There really isn't a lot out there. There's some peer-to-peer PubSub stuff out there, but as soon as you start not trusting nodes so much to play along with the rules, then it's kind of all falls apart. Eventually, Gordon, one of my colleagues, found a paper. It's called, let me check, Quasar, a probabilistic PubSub system for social networks. It's from the Cornell University, and I think it's in Ithaca, and it's, I think, somehow involved with Microsoft. I think one of their guys did it there. It's actually a pretty cool paper. The algorithm is very simple. It's like 250 lines of Python code, and you have it implemented, which is pretty good. How it basically works is it has a stack of Bloom filters, and the subscriptions of your neighbors, of yourself, go in the lowest one, of your immediate neighbors in the next one. Then in the next filter above that goes the first filter of your immediate neighbors. And so you kind of get this, they call them, what do they call them? Black holes or thing. It's like, if you send out a subscription on the network, it'll follow the filters sort of down into where the people that are subscribing to it. It works quite well. It has some drawbacks, like you can't have a content-based PubSub. Everything's only topic-based. To propagate the filters takes time because you have to do it in like a synchronized fashion. So every 10 minutes or 1 minute or whatever you choose the interval to be in, it'll like propagate it one level farther. So if you want to subscribe to something, it takes X times the filter depth to really get your subscription out there. There's also like, but in general it works pretty well. Ran a bunch of tests and there were no surprising outliers. The algorithm's solid. It does have drawbacks, like there's a lot of noise on the network just in updating the filters, and because it's like it happens at a concentrate, everyone's sending their filters every minute or whatever your time is. Like you have this level of background messaging going on. So like every peer-to-peer system, there are obvious losses in performance. Like it's just the way it works with every peer-to-peer system. Anyone, any questions at this moment about the functions? Excuse me? Oh wait, I'll give you the mic so you can.
Okay. What is PubSub?
Oh, it's just a simple comp sci algorithm where there are topics and users can subscribe to a topic to receive events for a topic, and publishers can publish this topic so that the subscribers receive it. It's, if you have independent nodes, it's a nice way to decouple the algorithm basically of whatever your distributed thing is from the actual communication. It's very common in distributed or systems. So, any other questions? Well,
so did you improve anything on the paper that you found? Did you do any changes, or did you just basically stick to it?
Yeah, there are a few changes. None are really relevant. The main change, which I haven't done yet, which I will do, is I will add proof of work to the messaging itself, because the network really suffers from traffic congestion, because everyone's updating their filters, and it's easy to just throw a whole bunch of messages and spam the network to some degree. So I will probably add a proof of work filter where if one node is maxed out on the income messages, let's just sort them by which has the most work, and then say these are the important ones and move them on, just to avoid spam and control congestion. I think that's the only relevant change. Other than that, it's pretty good. I ran a bunch of tests and there were no surprising things apart from that the main problem is just controlling this background noise from the network, and also, yeah, that's pretty much it. It is a probabilistic algorithm, so there's no guarantee you will get the subscriptions. There's like, it's actually pretty low for probabilistic algorithms. Like you have like a 98% chance or something that you will get the event, which is pretty low in CompSci. Like other probabilistic algorithms are way, way better in their chance of getting the output, but it's, because we're using it for a market mechanism, for publishing offers and bids, it doesn't necessarily matter if you get every offer. Like for a market to work, you just need to get the majority of the offers, and that's enough to keep people competing. If you miss an offer, then you might get a competitor, but it's not that bad as long as the market mechanism keeps working. If you have like a peer-to-peer program where you really need like almost 100% accuracy, then it probably won't work.
There's no way to improve this 98% to something better?
The paper did talk about some ways to improve it, where it could get almost 100%, and it also depends on how many levels up you go with your filters. We didn't look too far into it just because it was good enough for us. There are supposedly ways to improve it, but ultimately, like every basic internet protocol, like TCP or whatnot, it is a probabilistic algorithm, and there are chances that things will drop.
The 2% that are lost, are they randomly or arbitrarily lost, or is there like a method? Or is it something that's deterministic?
And I have not noticed any pattern where these 2% or why they get lost. The prototype I implemented, it's all on UDP, so a lot of this stuff is just from nodes having UDP collisions and stuff being oversaturated. I think if I move it to TCP, that'll probably drop another bit, but at some point I was like, this is good enough for us. I think we can improve it, but at some point you have to realize that losses are happening and you just have to account for those. And so, yeah.
Yeah, not to stick on it too much, but assuming you did just a simulation of the problem in a very neutral, right, kind of scenario, you would find the optimal or maybe the standard rate of loss, and then you would see how much of this is lost due to UDP. So I'm asking basically if this is a kind of test that's been made.
Yeah, I think so. Also, one thing I didn't mention is that the algorithm doesn't care about your network overlay. So I was using Cadmelia for the network overlay. That's pretty good. It gives you like 20 peers, which is enough. Maybe another network overlay would have a better performance. I was also using UDP that'll account for some losses. I also there is some issue with my implementation of the Cadmelia network overlay, or the one that I use. So I think there are some improvements there as well, that some of the loss is not actually from this algorithm, but from the shitty Cadmelia implementation. Because it's just a improvement, but for a first prototype, it's pretty good, and I'm happy with it.
Yeah, I have a question. As far as I remember from the paper, I have to dial back here a bit. Like every node is keeping Bloom filters of all subscriptions of the neighbor nodes, yeah, like these stacked filters. And now the problem is if you would publish something in the network, you would directly get it back because like your neighbor nodes would send it back to you because it would match. And that's where the paper introduces something like they call it novel, like negative information. Basically, they put also the node ID from the publisher into the Bloom filter, and yeah, and so somebody could look in the Bloom filter, is the node ID in there? If so, they wouldn't like forward it to that node ID. Can you follow? Am I like remembering this correctly?
Yeah, that's pretty much correct. There is, whenever someone passes on the event to their neighbors, they do attach negative information to it, so that it doesn't get a feedback loop. And yeah, that's.
But isn't this like the source of a lot of data loss actually? Because if packets actually match the node ID, they won't get forwarded. Like.
No. It's kind of like it attaches like a list of the trail where it's kind of gone to the packet, and so it'll know not to send that one back. It does. That's part, like the feedback is part of a lot of the noise that's going on. I haven't like I know there's some noise source that I can maybe cancel out, but it seems to work. I haven't done a complete analysis on why it works. I've trusted the paper thus far, and it does seem to work in the prototype. On how it can be improved, I don't know, but there is a constant level of background noise going on. Like one of the things I did was the filters are in the paper. The filters are updated periodically every like 1 minute or 10 minutes or whatever your choice is. And like if you change the algorithm so that it'll allow for extra updates when someone subscribes or something, like it pretty much immediately hits like some base. So it's at some point the network finds its maximum level of things that can pass around, and that pretty much becomes the limitation, which is why I wanted to add the proof of work just to control the congestion.
Do you like in the paper they propose that they propose to carry the negative information in the same Bloom filters as for the subscriptions, and that's like leading to some defect because the Bloom filter if the Bloom filters match like your node ID, you won't get forwarded the subscriptions or the packets for the subscription. And like did you get why they do that? I didn't really get that. And if so, why, or could you improve that by just putting the negative information into an extra Bloom filter and not using the same Bloom filter as for the subscriptions themselves? Like you're essentially making a blacklist where not to forward the information, and you're putting that blacklist into the same data structure as like where to forward it, and that's kind of.
Oh, it's like, I think there's definitely room for improvement, and it's definitely worth figuring all this stuff out in the algorithm. There's, like, my main point of using the algorithm was not to have like the most efficient PubSub. I didn't care if some information got lost or there was some amount of noise. What I cared about mostly was if most PubSubs work by sorting the subscription information into a tree. And the thing is, if you have competing nodes, like one might want to suppress all other nodes that have like a better offer than they do. So it's easy to attract one node in the subscription tree and then control the whole branch of the tree. And that's what we wanted to avoid. And so with this model, the messages kind of get routed around the network fairly randomly or in a duplicate manner, so that it's not easy to control like one part of the subscriptions. So that was our main focus, just to avoid people trying to suppress some sort of offers or control the market like that.
I have maybe two questions. So Storj is about creating a market for storage, right? And PubSub, and this is an implementation of a PubSub system. What's the place of this in Storj?
Well, it's storage, like as you said, it's a market for storage, and the question is, how do you implement the market mechanism? Someone has to be able, there has to be some way on your peer-to-peer network to make bids and offers. Like you have to say, I have this amount of storage for this amount of money over this amount of time with this bandwidth or whatever. And so you have to be able to make that offer somehow to people who are interested in this offer. And you have to be able to subscribe to that somehow. And in most peer-to-peer systems, this is not really, like, we searched far and wide for like peer-to-peer PubSub systems, and there doesn't seem to be much going on out there. There's like a handful of papers. As soon as you add to that you don't necessarily trust them, then you immediately lose 4 of your 5 papers, and that's pretty much it. It's how do you implement the market mechanism, that's all it's for.
So how does Ethereum Swarm do it? So how does Ethereum Swarm do it?
I cannot speak for them. I checked out the Swarm code a little bit. I didn't really see anything. Like 6 months back, I talked to a whole bunch of other developers, like the, what's it called, the peer-to-peer marketplace, again, the other one. Yeah, exactly, Open Bazaar, also with the, what's it called, IPFS people. Like there were 6 or 7 people we talked to with about peer-to-peer markets and things like that, and it seemed to be that everyone was like, my shit is the best, we're not sharing and whatever. Like no one really wanted to cooperate on like some common code for this general problem. So I don't know, it's just like everyone was more focused and wanted to build their own.
So they do have this problem? I mean, they do have similar problems?
The question was, do they have similar problems? I couldn't tell. I haven't looked too much in their code base. I've asked them how they're going to do it. I never got any answer that really helped me out. So go look if they have these problems or not. I don't know.
And how's Storj going? I mean, can you tell us anything about Storj?
To the progress of storage. Questions about the progress of storage in general, and I'd say it's pretty good. We're locking down a lot of things, like this prototype for the PubSub works. We're going to use this for now. I'm currently implementing micropayments for Counterparty. It's fair to say pretty solid system that people will be using. The question is, it's still in beta. Beta is a marketing term. It's like each component seems to work fairly well, and now we're like more attaching them together. So, yeah.
Can everybody use it already?
You can use it already, but it has its limitations. Like I'm currently working on the micropayments part of it, so the payments part of it isn't really integrated yet. So like, what is a market without the payments part of it? Yeah, it works, but it's not complete. So. The question is, who is the target audience? And I would say there's pretty much anyone who wants to buy and sell storage on a market is the target audience. There's several use cases of people who, what people are interested. Some people want to do video streaming because they think the latency of being able to stream from someone who is closer to you makes a difference. Some people, like myself, just want to store backups. There's a whole bunch of use cases.
How does the price for storage compare to centralized?
The question is, how does the price compare to centralized systems? And to be honest, I can't really tell you at the moment because it's a market mechanism. It'll figure it out. And that's how markets work. I assume it'll be at least the same or cheaper, because if it's a decentralized storage market, anyone can just take a centralized offer, attach it to the system for that price, and the only other way is down. Like it's not going to be more expensive. So.
So you were talking a bunch about game theoretic incentives and stuff like that, but I think you didn't. I don't remember you giving any kind of details. Are there any interesting like game theoretic concepts over there, or incentive systems and such?
Well, the main game theory is just like the basic game theory of every market system. There's nothing different there, really. It's just like free markets, how does it work, the game theory behind that. There's nothing really novel, I would say, about it. Like the novel thing we do is just we're trying to do a peer-to-peer market mechanism for storage, and all the other parts of it are known things, like markets, like the using decentralized currency like Bitcoin or whatever, like those are known components.
Can you tell a little bit about the connection to Counterparty?
The question is the connection to Counterparty. We currently use Counterparty. We have like an asset in the Counterparty. Maybe more to Counterparty itself. Counterparty is it works on top of the Bitcoin blockchain. So you can have your own assets on the Bitcoin blockchain, also do a whole bunch of other things like dividends and all sorts of stuff like that. And so we're using that. Basically, the reason for that is we think the novel part of Bitcoin or any cryptocurrency is proof of work. So you always want to be on the chain with the most work. And that's why we're on the Bitcoin blockchain with Counterparty.
What did you say about proof of work for your system?
In which regard? In the regard to the messaging?
You said you were implementing proof of work.
I said I want to implement a proof of work for the passing of the messages in the PubSub, just as a congestion control mechanism, assuming that if you do work on the messages, that it would sort the most valuable messages and use that as the mechanism to determine which ones it's going to forward and not. Just basic congestion control, spam control.
So about security, suppose I buy storage from someone and then I put my files on their system and then they disappear or they just say, okay, sorry, we lost your files. Is there anything to do about that?
Yes and no. On the one side, if someone just disappears off the network with your data, it's gone, but you are storing redundantly. Like you're not going to store all your data only in one spot. The client will split it across several nodes, and it will also like do basic checksums and redundancy. So it's more secured that way by having it across lots of nodes and by doing redundant storage. If a node disappears, it's gone, but we don't want to implement any sort of system to account directly for that loss, because then you start requiring judge, jury, police, and the whole thing. So it's better just to have them be punished on the market level by getting worse off, by getting less customers because of the loss they had, and you having your data secured by redundancy.
Or you can have them post a deposit, like in Ethereum.
The question is posting a deposit, but every deposit posting thing is, I'm not sure if that really helps the situation. You could post a deposit, but maybe not. Like, because every deposit like also ties up funds that could be used elsewhere, so it's always a trade-off. Yeah, it's not part of our strategy, but maybe it could be a good one. I don't know.
How will the price be able to compare to centralized solutions if so much redundancy is needed?
Redundancy is a sliding scale. You can have it as much or as little as you want. That's entirely up to you. If you want to have like a super redundant thing that has like 20 copies all across the network, then it's obviously going to cost more. If you feel like the top few offers are enough for you and you only want 1 or 2 times redundancy, then it'll obviously be cheaper, but you will be less secure. It's more of a sliding scale that you choose yourself as a client on the network.
At what point in time is the payment done?
The payment is done it depends on the contract, but it's in principle done the whole time. The way it works is we have micropayment channels, and that you keep paying over time as they store. So if you, for example, stored something for a week, then you could pay, depending on what the contract says, for the interval is like once a day or something over the time, so that if they disappear after day 2, they don't get any more money, or in more finite amounts.
How can I pay for it, and how does the party who's storing it receive the money?
The question is, how can you pay for it, and how does the party receive the money? Payment is in the Storj coin on the Counterparty network, so you have to buy those. It's paid for via micropayment channels, so you would open a channel with a hub and then pay over via micropayments and get it done that way. How do you get the coin? As with any coin on an exchange of some sort, pick your exchange. Go. Question from the internet.
Which layer in Storj ensures files are available? Does the renter run software that periodically checks, or does Storj check and remirror the files?
So let me just remember. Pretty much the person that's offering the storage has to be up, and they will be audited every once in a while. If your client is online, you can audit them. Also, one of the parts of storage is that we kind of like add another layer to that, so that you can defer that to another server that keeps doing the audits. So I don't know if that really helps. One way of putting it is also you can have a distributed ledger. That's what we're doing, and then it'll like put all the hashes of the audits into a Merkle tree, and then add that into the root into a blockchain, so that you can follow that and see that they had that data at that point in time.
Can you elaborate a bit more how the audits are working?
The audits work basically by when you upload the shard or the chunk of data, you build a tree with hashes against that, with seeds, and you give the node a seed for that it should hash the data against, and if it's able to produce the correct result, it proves that it had it. And so you can give it every time you want like an audit, you can give it the seed, and if it still has it, then it'll get the hash, it'll publish that into the Merkle root, which will ultimately end up on the blockchain. And that's a way of them for proving they had it at this point in time.
So about redundancy, did you think about using error correcting codes rather than just keeping the same channel?
Yeah, it's all error correcting codes. It's I'm not sure which algorithm we exactly used, as I didn't implement that part, but it's standard error correcting code. I'm not sure which one we're using, but
so you don't actually need redundancy per se.
Well, you do need error correcting codes are a form of redundancy. Like, it just doesn't mean you need double. It means you need like some fraction of it. It's you have like one it's like kind of two-dimensional. So on the one dimension you have the error correction codes, which give you some form of redundancy, and then you can just duplicate the whole thing. So depending on which parts of the grid go missing, if nodes go down, then you can like reduplicate from other parts. It's standard comp-sci redundancy, like RAID or whatever.
Okay, so 1.1. So it's actually not that much more expensive than just storing the file without redundancy.
Yeah, it's the standard redundancy codes like you would see in RAID or whatever.
What are the milestones? When are you planning to be?
The question is regarding the milestones, and I'm not sure. Sean organizes all the teams or all the people and what gets done, so I don't have the high-level view of that. I know I'm currently working on the micropayments part of it, and so that should be done in like, well, it basically is almost done, but it's like a ton of testing that needs to be done because it is money, and we need to know that that works. So, but yeah, it'll take a bit, but not too long. So I'm thinking in a few weeks, like micropayments will be working pretty well. How long that'll take to get upstream into Counterparty because the micropayments, we're gonna commit that into Counterparty itself instead of in our own software, so everyone has it. It takes time. I don't know how much time. We'll see.
So my question is about marketplace exploitation. There's many ways to exploit a centralized market, but for decentralized markets, one of the issues you talked about was spamming, basically, which is something you're obviously paying some attention to, but could you maybe talk about other exploitation mechanisms and kind of...
Well, because it is a storage market, peer-to-peer, it's subject to all the vulnerabilities that all free markets are vulnerable to, market cornering, things like that. There's not much we can really do about that. That's just nature and the way it is. Like if you go look at how free markets work, what are the good things and the bad things about them, all of this comes with it. So if you want to go out and try to corner the storage market, then you're free to do that. We can't really do anything against it.
Do you know other apps that are being built on Storj?
No, because I'm quite focused on what I'm doing. I know there are other apps, but yeah.
You know there are other apps?
I know there are other apps. You'd have to go to our site and ask about them. I don't really focus on that too much. I'm very focused on what I'm doing at the moment, and I know other people are building apps on it, but I'm not really actively following that very much.
You have something like a Slack channel?
Yeah, we have a Slack channel. You can just look for Storj Community on Slack and you'll find us. We're thinking about transitioning away from Slack because we kind of maxed out Slack. There's no one really can join anymore. We're having to kick out deactive people, so we are finding a new place to go, but currently we're using Slack. Any other questions?
How does it compare to another similar project,
Too
SIA?
much about individual competitors. What I can say is that I see a lot of people trying to make like mix blockchains with file storage, and which I don't really see a reason for. So I think that's ultimately a failure, but that's for them to make. Yeah, I can't comment too much about competitors, but yeah.
Could you just say something about the size of your team and how many people are working for how long?
The size of our team and how many people are working for how long. I would say we're about a dozen people. It really started picking up about almost a year ago, where we started hiring a lot of people. Like I've been here for just under a year, and so a lot of people started coming in after that, but we're still about a dozen people. As for low-level developers like myself, we're only like 3 or 4, which is okay. It's not like other projects to try and re-implement the internet in a different way or something. Like it's a very focused effort. And excuse me?
When you're saying you're low level, that means opposite to...
The question is when I say low level as opposed to like UI and stuff like that. Yeah, exactly. When I say low level, it's like software that only other software uses. It's kind of like high level users use that. So.
This might be out of the scope of what we're talking about, but if Storj.io will start the market at 0.015 cents per gigabyte per month, that's from the homepage, will they be paying farmers using SJCX purchased from the public coin markets or from the unallocated stockpile?
That is a good question. I actually can't answer too much about. That's that would be a better question for Sean directly. I'm not really too on current with how this exactly is going to happen. I'm just like implementing the software parts of it. I'm guessing if Sean says we're starting at that price, then obviously we have storage going in at that price, and that's going to be how it starts, what the market will ultimately end up at for which price in which storage part. Like there's obviously different storage models, long-term storage, short-term storage, things like that. We'll see.
I would like to go back to checking the availability checks or the audits of providers. Does the auditor need all the data the storage provider stores to be able to verify the hash that the provider submits?
So yes, the person that's storing the data requires all the data to prove that they have the data. That's how. Yeah,
does the auditor need all the data?
Oh no, the auditor does not need all the data. The auditor just needs to know the resulting hash and needs to know the seed that it gives the node that's storing the data. So it just needs two hashes. It gives it the seed hash and it gets the resulting hash back. If they match, then it matches. It does not need to store the data.
But how will it know the resulting hash?
It knows the resulting hash beforehand. The auditor does not know that. It's part of the process. If you upload a file, you build this tree of resulting hashes, you keep that a secret to yourself, and then every now and then you give them a seed and see if you get the correct one back, and then you know they have it. More questions?
At what point does the auditor build this hash, this secret?
The question is, at what point does the auditor build this tree? At the very beginning. That's like part of the file upload process. This happens when they upload the file. So you start uploading the file, and then in a certain number of streams, you start hashing the thing in parallel, and then you build this tree. So it's part of the upload process.
So what happens if an auditor goes away or drops from the network?
The question is, what happens if an auditor drops from the network? Ultimately, the auditor is mostly the client itself. So if the person that's interested in the files drops from the network, then it doesn't really matter. That's Any other? That's it? Any other PubSub questions? No?
You mentioned that you could see quite a lot of improvements based on what you've read about Quasar.
Excuse me?
You mentioned that there is a lot of room for improvements in what you found in Quasar. Can you highlight any of those?
I wouldn't say a lot of improvements. I would say some improvements. Like, obviously, there can be improvements made on congestion control in the network and deduplication, or if you want to, deduplication is like the same thing as reducing redundancy. So at the moment, we kind of want to keep it because this redundancy reduces the fact that someone can suppress some messages. So it's a good and a bad thing. But there are some improvements, but in general, regarding upping the possibility of getting the messages, there are some improvements to be made, but not many really. It's sufficient. So.
I have a question about the audit part, but I don't know, it might be too technical. I don't know if it's interesting.
It's all right.
So just answer me offline if you want to. So about the auditing part, you said you compute a Merkle tree from a bunch of seeds, a bunch of Merkle trees from a bunch of seeds on the file in advance, and then you audit, you send the seed, and you see that you get back the right thing. Right? Why not? It seems like expensive. I mean, computing a Merkle tree is really expensive because you need to hash all these times. Why not just choose, just do an inner product, like an XOR of around half the bits, where the set of bits that you're XORing is chosen randomly or pseudo-randomly from a seed. That way, you'll have all the challenges in advance, but it will be really quick to compute the authentication results, and it will be as secure as far as I can see.
I think this is kind of like a misunderstanding of what takes time and what doesn't. When you upload a file, the slow part is the uploading or the reading from the disk. To hash the data that you're uploading in parallel costs 0 time. There's like instructions on Intel processors for it. It's like really fast. Like hashing stuff is not slow at all. So you can, if you have like, I don't know, 100 audits you want to make, hashing that data as you read it from disk 100 times is really not a problem at all. It's hashing stuff is cheap. And
What hash do you use?
currently we use the Bitcoin hashing strategy. So it's SHA-256 and then RIPE-MD-160. Ultimately, it doesn't really matter. It's up to the client because the protocol only knows of data shards and encrypted blocks, like how they were derived, what they were built from, or how they're hashed is not part of the protocol, really. Like you can say hash this with this in the contract with this hashing algorithm and this seed, and then it'll do that. But how ultimately you could choose a different algorithm to encrypt it, to hash it. It's not. It's pretty flexible. It doesn't really matter too much.
How do you determine how many hashes you keep, like for auditing?
The question is, how do you determine how many? That is really part of the configuration of the client. If you want to have only one hash in the beginning and the end, like you do that. If you want to have hundreds over years, then you do that too. It's just part of picking where you slide your scale in the configuration. Maybe to just elaborate on that, there are like different storage use cases. Like you may have like, what is it called from Amazon, the one where the Glacier, I think, where you want to store something for quite a long time but not need access all the time, like just once a month or something, see if it's still there, and in the meantime, because they know this once a month is coming, they can like just have it on tapes or whatever. There's like different models, and we don't really want to drop one model or not. We just want to keep it flexible, as flexible as possible in the contract, so you can define it as you need and then let the market sort everything out.
Isn't this kind of a high barrier if you start with directly with a coin, with a Storj coin? Wouldn't it be easier to be able to pay in fiat currency? I mean, is this not?
I think that's more of a philosophy debate than anything else. Like in fiat currency would mean you start adding Visa and all that stuff, and then you have to deal with chargebacks, which is the real problem. And so it's easier to use a cryptocurrency just because it's easier to program an algorithm against cryptocurrency than it is against Visa with chargebacks and stuff like that. You could do it with Visa or whatever, and that wouldn't necessarily be a problem. But
There are no plans in the near future for this.
the question is if there are plans in the near future for this. I actually don't know. You can implement, I mean, there's nothing stopping you from implementing a client that uses Visa on top of this, and I'm sure it will happen. Yeah. Then, since there's no more questions, I think we'll call it a day. All right. Oh, free t-shirts.